So let us try to illustrate how the system of equations here can be solved manually. You can make use here of your Gaussian elimination method. So I believe they have teach you last time regarding how to perform your Gaussian elimination method. However, what we will be using today is the systematic Gaussian elimination method, because there are two ways on how you can perform your Gaussian. It's either by systematic or using your row and column operations. So first part is, let us construct your augmented matrix form. Your augmented matrix form is obtained by forming the rows and columns corresponding to this system of linear equations, wherein the columns will be arranged depending upon the numerical coefficients of your unknown variables b sub 1, b sub 2, and your constant. This is your equation 1, equation 2, and equation 3. So if you will start, the numerical coefficient of your variable b sub 1 in equation 1 is 0.75, and for b sub 2 is negative 0.5. The numerical coefficient of b sub 3 from the first equation, since it is not provided, that is understood to be 0. And the constant in the right side is 2. And doing the same in the second equation, the numerical coefficient of b sub 1 is 0.5. The numerical coefficient of b sub 2 is negative 0.667. And for b sub 3 is 0.167, and the constant in the right side is negative 3. With the last equation, the numerical coefficient of b sub 1 is understood to be 0. This one is 0.167. b sub 3 is negative 0.292, and this is negative 7. This is now your augmented matrix form. Okay, so if you will try to draw a line connecting all your elements within the principal diagonal, this element must be converted into 0. Okay, so this will be 0.75, negative 0.5, 0, and 2. That is 0. There is no problem with this because it is already 0. So all you have to do is to recopy it. 292 and negative 7. Okay, how do we find now the new value of these elements? Okay, let us say that this one is A1, A2, and A3. Okay, so that will be for A1, this element of negative 0.5 times the negative reciprocal of your pivot element, which is 0.75, times 0.5 minus, or plus rather, plus 0.667. Okay, plus negative 0.667. Yeah. And for a sub 2, this is 0 times the negative reciprocal of 0.75 times 0.5 plus 0.167. Naturally, this is 0.167. And for a sub 3, that is 2 times the negative reciprocal of 0.75 times 0.5 plus negative 3. So if you will try to compute now for this, the values will be this is negative 0.333, the other one is negative 4.333. If you will try to recheck this one, that will be negative 0.5 times negative 1 divided by 0.75 times 0.5 plus negative 0.667, and the value is negative 0.333. For a sub 2, that is 0.167. For a sub 3, that is 2 divided by negative 0.75 times 0.5 plus negative 3, and the value is negative 4.333. So if we try to write this down in the space allotted, 0.333, 0.167, and negative 4.333, so that we are now free to erase this portion. Okay, and we will only be dealing with this part of the augmented matrix. Ito lang, yan lang. Okay, so if we try to write these elements down, negative 0.333, 0.167, negative 4.333, and replace this with 0 and determine these new elements, supposing that this is B1 and that is B2. Okay, the value of B1 now, your pivot element will now become negative 0.333, so this will be 0.167, correct? 0.167 times the negative reciprocal of negative 0.333 times 0.167 plus negative 0.292. And for B sub 2, that is negative 4.333 times negative 1 all over negative 0.333 times 0.167 plus negative 7. And the values that you should be getting there is negative 0.208, and the other one is negative 9.173. Okay, you can check that. This is negative 0.208. This is negative 9.173. Okay, let us try to compute. It's 0.167 times 1 divided by 0.333 times 0.167 plus negative 0.292. Okay, negative 0.208. The other one, plus negative 7, and that is negative 9.173. Okay, so what we will be doing next, actually to complete the solution, is for you to write down the entire matrix. 0, you try to write down the entire matrix. This is 0, 0.75, negative 0.5, 0, 2. This is also 0. Okay, and it boils down to having this augmented matrix form converted into a lower triangular matrix. To help you refresh your mind regarding a triangular matrix, a lower triangular matrix is a matrix whose elements below the principal diagonal are all zeros. These are the zero elements. Okay, going back now, if we try to bring this back into its equivalent linear form, starting at the third row,